Let's look at adding, subtracting, multiplying, and dividing functions. For this first example, we have f plus g of 5. So let's rewrite our problem as f of 5 plus g of 5. So we're taking the value of 5 and plugging into each function. First, if we plug 5 into f of x, which is x squared plus 3, we get 5 squared plus 3. 5 squared plus 3 is 25 plus 3, and that gives us 28. When we plug 5 into g, we get the square root of 5 minus 1, which is the square root of 4, and we know that the square root of 4 is 2. Therefore, 28 plus 2 is 30. So f of 5 plus g of 5 equals 30. So example 2 is very similar, except we are subtracting f minus h of 2. So let's rewrite it. F of 2 minus h of 2. Let's first find f of 2. If we remember, f of x is x squared plus 3. Therefore, plugging 2 in, we get 2 squared plus 3. That gives us 4 plus 3, which is 7. Now we're going to subtract h of 2. So let's plug 2 in to h of x. Now if you look up at the top, h of x is 1 over 3x minus 2. So let's take 1 over 3x. We're plugging 2 for x. So we get 1 over 3 times 2 minus 2. This gives us 1 over, and 3 times 2 is 6. 6 minus 2 is 4. So we get 7 minus 1/4. Now we want to put our answer in simplified form. And to do this, we need to combine these into one fraction. So let's get a common denominator. 7 minus 1/4. To subtract the 2, we need a common denominator, and the denominator that's in common would be 4. So let's convert each fraction to something over 4. 7 can be converted to 28/4. And of course we already have 1/4. Therefore, now we can say 28 minus 1 all over 4, which gives us 27/4. And this is our answer. So here we have some more examples. I copied the functions from the previous page so we would have them to reference. And we're looking at, in number 3, g times h of 1. This represents multiplication, so we are multiplying g of 1 times h of 1. Okay, so this time our x value is 1. So we want to take 1 and plug it first into g of x. That will give us, let's see, g of x is x minus 1. So that would be 1 minus 1. The square root of 0 is 0. Then we have h of 1. Now remember, h of x is at the top of our page, and it is 1 over 3x minus 2. So let's plug 1 in for h, and we get 1 over 3 times 1 minus 2, which gives us 1 over 3 minus 2, which is 1 over 1. Therefore, g of 1 is 0, h of 1 is 1, and 0 times 1 is 0. Now let's look at number 4. F divided by g with respect to 5. So let's rewrite it. This would be f of 5 divided by g of 5. Okay, so let's plug 5 in for f of x. We've actually done this before, but let's do it again. F of x, as we know, is x squared plus 3. So 5 squared plus 3 gives us 25 plus 3, and 28. In the denominator, we have g with respect to 5. We have, what is that, the square root of 5 minus 1, which we found earlier too is the square root of 4, which is 2. Therefore, f of 5 divided by g of 5 is 28 divided by 2, and we get 14. So now let's talk about composite functions. For number 5, we have f of g of 10, and this stands for the composite function. We can always rewrite the composite function just in a different form, where we have f, and then g of 10 is what we're plugging into f. So let's find g of 10 first. So we take the function g, and we plug 10 into it. Remember, g of x is the square root of x minus 1, so let's plug 10 into the function, and we get the square root of 10 minus 1, which is the square root of 9, which is 3. So now we're going to plug 3 into f of x. So remember, we have f of g of 10. Now remember, we just found that g of 10 is the number 3. So we're going to take 3 and plug it straight into f of x. Now if you remember, our function f of x is x squared plus 3. But instead of our x, we replace it with 3. So that gives us 3 squared is 9, and 9 plus 3 is 12. So my answer is 12. Sometimes we like to write it as a shortcut, just to show you. Basically what we're doing is we're taking 10, we're plugging it into g, and we found that to be the number 3. And then we're going to take 3 and plug it into f, and we found that to be 12. So let's look at number 6. We have f of g of h, all with respect to the variable 1. So this is a composite function, and we work from the right back towards the left. So we basically are going to take 1 and plug it into h, then take that and plug it into g, and take it back and plug it into f. So let's start by finding h of 1. Okay, so h, as we know, is 1 over 3x minus 2, but I'm plugging in 1 for x. That gives me 1 over 3 minus 2 is 1, so we get the number 1. All right, so we got 1. Now we're going to take 1 and we're going to plug it into g. Okay, so g of 1, let's go back and get the function g, which is the square root of x minus 1. Let's plug 1 in for x, so that would give you the square root of 1 minus 1, which is 0. 0. Okay, so now that we have 0, we're going to take that, and one more time, now we can plug it into f. f of 0. Let's see, f is x squared plus 3, and we're plugging in 0 where we see x. So we get 0 squared, which is 0, plus 3. 3 is my answer. So if you look at the actual problem, just to recap what we did, we took the number 1, we plugged it into h. That gave us the number 1. Then we took 1, we plugged it into g. That gave us the number 0. And then finally we took 0 and we plugged it into f, and that gave us the number 3. So 3 is our final answer. Okay, so now we are looking at an example where we're adding two functions, and we're letting 1 be the value of x that we want to use. But the only definition of the functions is by a graph. So if you look at this graph, you can see that f is represented by the red graph and g is represented by the blue graph. We're going to use these to help us find our answer. So we have f plus g of 1. Remember, 1 is the value of x that we want to use. So we can rewrite this as f of 1 plus g of 1. So we need to find each value. Let's first look at f of 1. So when you're dealing with graphs, remember 1 is our value of x. F of 1 represents a y value on a graph. So f, the function f, is the red graph. Let's look up f of 1. If we look up 1 on the x-axis, we have it right there. There's 1. So f of 1, we come right up here, and it's the red. That's our point. F of 1 is the y value, which is also 1. So that's f of 1. Now let's look for g of 1. So we're looking up g, which is the blue graph. So when we look up the x at 1, see, here we are still, but let's find what g of 1 is. It's up on the blue graph. It'll be right up here, and that's at the number 3. So f of 1 is 1 right here. G of 1, you just go over here, find 1, and then go up. And there's my g of 1, which is the number 3. So we have 1 plus 3 is 4. This is how we use the graphs to help us find our answer. Here we have f minus g of 3. So let's rewrite it first. F of 3 minus g of 3. And just like the last example, we're going to use our graph, the same graph. This time our x is 3, so let's find f of 3. So our x value is 3, right here. So f of 3, remember f is the red, so when x is 3, we go up, and there's our point. Remember, f of 3 is the y value, so f of 3 would equal 1. Let's find the same for g of 3. Okay, we're still finding the same x value, which is 3, but g, remember, is the blue function, so when x is 3, we went over and we found 3. But this means we have to go down. Looks like it's right here. It looks like that's at the value of y equals negative 5. So we basically have 1 minus negative 5, which is 1 plus 5, which is 6. So in this example, we are multiplying f times g of 0, so that would be f of 0 times g of 0. So just like the last example, let's use our graph. Let's first find f of 0. So we have x equals 0, which is right in the middle. Our f function is the red function, so let's find the y value. When x is 0, we go up, and we find right there. That looks like that is at y equals 4. Now let's do the same for g. So when x equals 0, the g is the blue function. We go up. Looks like it's at the same point. So g of 0 is also 4. Therefore, 4 times 4 is 16. That's our answer. All right, so now we're going to look at an example of a composite function. So I'm going to rewrite it first. This is f of 2. Remember how this works. We work inside out or from right to left. So we're going to take 2 and plug it into f first. Then we'll plug it back into f again. So let's look at f of 2 first. Using our graph, our x value is 2, and f is represented by the red graph. So when x equals 2, y equals 0, right there at the point. So f of 2 equals 0. Okay, so we got 0. I'm going to replace it right there. So here we go again. We're going to now find f of 0. So now our x value, our new x value is 0. So let's come over to the graph. When x is 0, right here, right in the center, f, where's our y value? And f is the red graph. So it's 0. Let's go find the point on the red function. It's right there. That looks like that's at positive 4. So my answer is positive 4. All right, for this example, we have another composite function. We're starting with the value x is negative 1. And remember how this works. We can work from the right side back to the left. So I'm first going to take negative 1, and we're going to plug it into g. So I'm going to write it right here. Let's find g of negative 1 using the graph. Now remember, g is represented by the blue graph, and our x in this case is negative 1. So let's find the point on the graph. Remember, g of negative 1 is your y value. So when x is negative 1, let's go over here. Here's negative 1 right there. G is right here up at positive 3. So g of negative 1 is positive 3. Now, so we got 3. Now we're going to take 3, right, and we're going to plug it into f. So let's find f of 3. Now let's look at it again. We're talking about f, and f is represented by the red graph. In this case, we're going to take our x value to be 3. So let's find it over here. When x equals 3, we have it right here. And let's find the point on the function f, which is the red. So at x equals 3, we get the point right here. Our y value is positive 1. So f of 3 equals 1. And one more time, we're going to plug it back in. We work from right to left. So this time, we are plugging it into g. Again, so g of 1. Let's find it on the graph. So our x in this case is 1. So if we start at 0, we go over to x equals 1. Let's find the point on the graph g. Remember, g is the blue graph. So at x equals 1, y equals the value of 3. My answer is 3. So just to recap, we took negative 1, we plugged it into g, and we got 3. Then we plugged 3 into f, we got 1. And then we plugged 1 back into g, and this gave us the number 3. 3 was our final answer.